Hello, welcome to Introduction to Java Programming. In this session, we learn about inheritance, the basic uh, parts of the inheritance, namely what is inheritance, what happens when there is inheritance among classes, how to specify inheritance, etc. Let's begin. So we know inheritance is one of the major object-oriented principles. So we have four principles of object-oriented programming. So namely encapsulation, inheritance, abstraction, and polymorphism. So mostly inheritance and polymorphism will be closely together. So whenever you have inheritance, of course, polymorphism also will be there. We will understand that. So inheritance is one of the major object-oriented principles. So it's a pillar of object orientation. So if inheritance is not there, then we call that language as object based. An example, JavaScript, VBScript, they all have objects actually, but there is no inheritance. Okay, yeah, OBL means object based languages, and few languages are OBL also, where there is no inheritance that can be specified. What is inheritance? Inheritance is the process, inheritance is a mechanism where a class will acquire properties of another class. So that means at least you should have two classes. One class will be acquiring the properties of other class. Of course, this inheritance is a real world thing. It has taken from the real world only. So we all inherit properties from our parents, right? We acquire properties from our parents. In the same fashion, a class acquires properties from other class. Okay, the class from which the properties are acquired is actually called as a parent class. Then the class that acquires is the child class. Of course, it's also called super or base, and from which we acquire properties. And the classes which acquire properties are also called as child, sub, or derived actually. Okay, so these are all synonyms. When you say parent, then it is child. When you say super, then it is sub. When you say it is base, it's a derived class. You have a class already written and it's working fine, and you need not to start from the beginning, you need not to start from the scratch. Rather, you can inherit it and straight away you can use it. So that's what exactly about inheritance. In fact, in Java, all classes will form a hierarchy. All classes will form hierarchy. That means in any hierarchy, there at the top there is something, and later we have all other branches coming down, right? So in the same fashion, in Java, we have on the top of the class hierarchy, there is a class that is called object class. So object class is considered to be the super class of all Java classes. Okay, and any other class, which is actually a child class of the object class, because at the top you will have this object class as the super class. You can actually go to the documentation and check in the lang package. There is a class which has no parent, but all other classes have parents. And how to identify inheritance? So whenever you are modeling a solution to a problem, how to identify inheritance? So this can be done by identifying a relationship that's called is a relationship or generalization by specialization relationship. So as an example, you can actually find many things like that, right? So a student is a person, dog is an animal, employee, technical employee is an employee, classic customer is a customer, right? A rose is a flower. So whenever you see this is a kind of relationship, there is a hierarchy, and that we can model as inheritance. So this relationship is also called as generalization by specialization relationship. The parent class is generalized class and the subclass is the specialized class. Okay, so from modeling the solution to a problem, whenever you find entities and the relationship is easy relationship, then you can actually go for inheritance. Okay, so we have easy relationship possible as inheritance, and of course we can see mostly has a relationship association. So that I will actually take on later. Yeah. So now in the context of inheritance, what exactly is happening? A class is acquiring from other class. Okay. So usually what a class contains? A class contains data members. A class contains constructors. A class contains methods. A class contains static blocks. A class contains some nested classes. So these are all what are all possible in a class. Now, when you specify inheritance, what happens to a subclass? Okay, so only the non-private members of the parent class are inherited. Only the non-private members. Anything which is private in the parent class is not going to get inherited to the child class. Okay, we say acquiring all the properties, but non-private members are only inherited. Private members are not going to get inherited. Even the constructors which are there in the parent class are not going to get inherited. Okay, so through inheritance, what is going to happen is from a superclass, a subclass can acquire all the non-private members. All the non-private members, they are data members, they are methods. We know constructors are not inheritable. And this subclass can also have its own members, Not just the properties it's acquired, it can also have its own members. Not only just having its own members and getting all the parent members, the subclass can redefine the behaviors of the parent class. Behaviors means methods. Methods are inheritable if they are non-private. Now a subclass can redefine it. So that redefinition is actually called overriding. Okay, so of course we are going to discuss all these things thoroughly, and I will give you an illustration also how and what is going to happen in an inheritance. And before that, and what are the advantages by having this, by having inheritance? What are the advantages we are going to get? So we have straight away code reusability. We can reuse the code. A class is already available and you are just inheriting it. So everything is available to you and you can reuse it straight away. So that actually fosters rapid application development. The faster application development is possible, and code sharing is actually possible among the project. So I have created a class which is a generalized, and anybody else in the project can actually extend that, and they can actually use that to solve the problem immediately. So they need to start from the beginning. Okay, so ultimately, inheritance actually provides us code reusability. So because of the code reusability, you can actually share the code sharing is possible and faster application development is possible. And finally, how to specify the inheritance in program. So we have a keyword out of the 53 keywords of Java, something called extends. So extends actually is to specify the inheritance. So now let's understand this thing with an illustration. So let me actually make up an illustration over here. Let me have a class over here. Let's say this is the class A, and I have another class. So this is the class B. I'm having two classes, A and B. So every class will actually have data members and methods. Basically, of course, constructors also can be there. Yeah, so let me actually write the names of these classes. So this is my class called A. This is my class A. And this is going to be my class B. Okay, so usually we'll have data members. These are data members here, and these are method members. Later, of course, we'll have constructors also. So what we are saying through inheritance is all the non-private members of the class are available straight away through inheritance. So non-private members. So all the non-private members which are data are available over here, and all the methods are also available over here. Okay, which are non-private. When they are available, whenever you specify the relationship, that is a relationship. Okay, so then whenever you specify something like this, class B extends A. Now you can actually have all the things coming over here. So I have a class B which extends A. That means this class A is acquiring from this particular class A. What are all available? All the non-private members of this particular class A are straight away available. If they are private, they are not available. And all the non-private members of private methods usually public, so everything is available to you. And data usually will not be public. That's not available. But through methods, we can actually access them. That's what encapsulation, right? And sometimes what we can do is we can actually use a keyword called protected. So we have the visibility specifier protected, especially it is used in inheritance. So all the protected members are designed for child classes only. You have some protected member in the parent class that is straight away available to you in the child class. Okay, so this is something about the inheritance. So to happen, inheritance to be happen, at least you should have two classes. And of course, there are different kinds of inheritance we have. So this is kind of a single inheritance because one parent and one child. And you can have multi-level inheritance also. That means a class acquires from this class and this class acquires from other class. We can have a chain of hierarchy that is called multi-level inheritance. And then we have multiple inheritance also. So that means from two classes, a single class is getting acquired. So from father and mother, you are acquiring the properties. That's actually multiple inheritance. Okay, and we have something called hierarchical inheritance also, where you have where one or more classes are getting acquired from a single parent. Okay, so like that we have different kinds of inheritances which are available. Yeah, so with this, now let's actually specify the inheritance as a program. Okay, how we can actually do that. So as I told, inheritance is a process of acquiring properties of a class by other class. So that means you should have some class that is available and which you are interested in and you want to inherit. Okay, let's assume I have a class called employee. Okay, so here I have a class written. An employee class will have some data. So I have made my class employees fully encapsulated. So you know what is fully encapsulation? So all the data members are private. So I have employee ID, employee name, and a basic, some salary, right? Basic means basic salary. And I have an employee working for some organization, let's say that is Google, and which is a static variable. I have made all my data as private. And I have a setter, set employee, and I'm setting all instance members. And I have a getter that is the disp method, which is actually displaying all the 4 data members. So this class is there, and this class is already available and it's working fine. That means it's compiled. Okay, and we can actually so when it's compiled, we can actually have the dot class file available. So java emp, this is the dot class file. And since I have not writing any constructor, default constructor is also available over here. Okay, so now whether this class is working fine or not, so what I'm doing is I have a driver class over here. The driver class, you know, that is the main class. And from here, I'm creating an object employee E1 equal to new employee. I'm creating an object with by invoking the default constructor. I'm setting the employee ID, employee name, and employee basic, and I'm actually displaying it. So let's see that employee class is working fine or not. So now let me actually compile this driver class Java C driver.java. It's compiled and let's see whether it's working. Yeah, it's working fine actually. So that means I have a class which is working fine, which is tested, which is debugged, and it is working fine. Okay, now I have a similar requirement. So now when I'm modeling the employee management system, so now I found there is a specialized class, let's say technical employee. So in an organization, you have different categories of the employees, right? Technical employee is an employee, admin employee is an employee, regular employee is an employee, outsourced employee is an employee, contract employee is an employee. So we have different kinds of employees who are working actually. So I have the generalized thing. So every employee, whatever the employee is, whether technical or admin or outsource or contract, whatever it is, everybody will be having an employee ID, employee name, and he works for some organization and he will be given certain salary, right? So this is the generalized class for me. Now I would like to go and write a specialized class, right? So I'm going to use inheritance concept over here. So inheritance, I can straight away get this class employee. So now what I'm doing, I'm going to write a class, public class, technical employee. I would like to have a technical employee. Let me save this as technical employee here itself in practice.java, technical employee.java. I would like to have the class technical employee. And technical employee is also an employee, right? So what I'm doing, public class tech employee extends. So this is how I'm specifying, extends employee. Okay, so by the time I say extends, what is going to happen here? All non-private members of this employee class are available here. So what are all the non-private members you have over here? So all the methods, right? So set employee is available and this method is also available. So that means here you have the set employee, which is actually constructing some data, and you have the this method straight away it is available. You can actually use these two methods to access this data, right? Because data is directly not available because it is private, only non-private members are available. So this private data is not available to you, but you are available with these public members. So through these members, you can actually go there and get it, right? See here, I have nothing actually. I just specified the inheritance. Now what I'm doing straight away, I'm writing a main method over here. And now I am actually creating my technical employee object. Techemp, some TE equal to new techemp. Okay, so since I don't have a constructor, default constructor is applied to me, an object is created. And object contains what? Does this object has any data? Does this object has any data? Yes, it has certain data, because this tech employee extends this employee, and this employee has some data, right? And this employee has a constructor, default constructor. The default constructor is going to construct these instance members with the default values. So now here, the point one has to understand is, whenever this this constructor is applied to me, public tech emp. Okay, so in its definition, there is actually one more thing is applied to me, that is super, a super keyword actually, super with parenthesis. Okay, we will discuss this thoroughly, but as of now, understand this point. Whenever a tech employee constructor is applied by the compiler to me, it also supplies me the super constructor. What this super constructor will do, it actually goes and finds the super class, and it actually constructs the default values of this particular uh, object. Okay, so object variables like EID, ename, and basic. So here what is going to happen, you are going to have a technical employee object over here. Okay, a technical employee object is getting over created, in which you will have EID, ename, and basic, which are set with the default values. Okay, even though you don't have any values, through your parent, you are getting an object which has EID, ename, and basic set with default values. Now what I can do, I can actually have direct methods available through inheritance. Now I say t1 dot set emp, and I can set those eid, ename, and basic with certain values. Okay, now what I'm doing, I am saying, so first I need to pass eid. Let's say 321 is the eid, and the name of the employee is XYZ, and he has certain 99,000 is actually the salary, the basic, right? And now when I say te dot disp, when I say te dot disp, now what happens? It goes to the disp method because the disp method is available. These two methods are available, right? Set employee is available. This is a public method, and of course, I was available with this disp method also. This is also available, so I can use that directly with my technical employee, right? And let me actually show you that this is going to work. Let's see. So Java C tech employee dot Java compiled successfully, and when I say Java tech emp, now you can actually see the data here. You can actually see the data 321 XYZ 99,000 and Google. So how this is possible? This is the beauty of inheritance. Okay, I said a class can acquire properties from other class. So my other class is an employee class, parent class, and my technical employee is acquiring those properties straight away. I have written nothing actually over here in my technical employee. So this is the first point, whatever actually I'm explaining here in the inheritance. A subclass can acquire all non-private members of its superclass. Okay, this is only the first point. So here I am just specifying the extends keyword, and all of my employee things are available to me. But private members are not available, but through methods I am able to get it. And one more thing, what is actually happening here, so let me annotate and tell you, this is important to understand. So here for the line number 7, whenever you say tech employee te equal to new tech employee, now an object has to be get created, right? An object has to get created in the heap memory, that is tech employee. Further, there is a constructor, but this constructor has nothing to construct because no data members are there. But this constructor has a super call. So this super call actually go to the parent. In the parent constructor, there are EID, ename, and basic. So that will be called as part of the technical employee. So here what happens? So here the EID value is going to get set with its default value 0. Ename is actually getting set with its default value null. And the basic is getting set actually with the default value 0.0. That's what actually happening by this line when you say new tech emp, because a super call is going to happen. The default constructor that is applied in the child class has a super call, because there is a rule. If you have to construct a child class, you have to construct your parent class first. So that's why super is applied to us. So that means by the line of by when we finish the line number 7, so we'll have this one, and of course we have a reference actually coming back. So that is that reference is actually te. Now te dot set employee, because I have set employee straight away available, because that's a method, it's not private, straight away that is available to me, I can call it with my reference variable te, because I'm a technical employee class. I'm a technical employee class, and I have this set employee available. So now t dot set emp. Now here we are actually setting the data. So here I am saying 321, and here I am saying XYZ. So that means these values are getting replaced, and here I will have certain 99,000. Okay, and once it is set, it will come out, and then we are calling t dot disp, and the disp actually will display. So we have written a disp method. What we did, we asked to display EID. So 321 is going to display it. After giving space, we are displaying the name, that is XYZ. Then basic also we will be displaying, and that's going to be a double value. So it will be like this. And of course, in the display method, we are actually going to our class area to get the arg value. So org is actually in the class memory because that's static value. So actually that is actually Google. So this is what actually getting printed by this. Okay, so this is what actually happening internally when this happened. So just by specifying this extends keywords, all of this is actually going to happen. So that is actually the power of inheritance. That's the beauty of inheritance. Okay, yeah, so let me actually go back to this one here. Yeah, what we discussed, what is the summary? So inheritance is the major principle of object-oriented programming, where a class acquires from other class, and there are different conventions: parent, child, super sub, and base derived. And only non-private members are inherited. Private members and constructors are not inherited. But in order to access the parent class constructors, we have a super keyword. So that I will tell you in inheritance part 3. Okay, and yeah, we have seen how a class acquires all the non-private members. We have seen now with an example. Only part 1 we have seen. Then this one, how it has its own members, how it redefines, that we are going to see in inheritance part 2. And inheritance part 3 we are going to discuss about super. Okay, and overall the advantage of inheritance is code reusability. So we have just seen, we have an employee class which is available straight away. By just saying extends, I could actually have a technical employee class. I could able to create an object. I could able to call methods on it, and I can do my job done actually. So this is what actually I'm doing here, right? Nothing doing actually. I have no business, but there is something happening. So that's the beauty of inheritance. Hope you have understand this, and meet you with the inheritance part 2. Thank you.